Hello everyone, welcome back. Hope you all are doing great. Guys, today in this video again we are going to troubleshoot the network. We are going to troubleshoot one ticket, and ticket is, as you can see here, customer is complaining that PC1 is not able to access PC2. You need to troubleshoot the connectivity between both LAN. Okay, so here you can see LAN 1, here you can see LAN 2. In LAN 1, I am running network 192.168.10.0/24, and in LAN 2, I am running network 192.168.20.0/24. Between routers, like between router 1 and router 2, definitely I am using a routing protocol. We will check, we will verify that routing protocol. But before that, you can see the IP address of PC1 is 192.168.10.1, and gateway IP address is 192.168.10.254. And PC2 have IP address 192.168.20.1, and PC2 have default gateway 192.168.20.254. First of all, I am going to verify the problem, guys. Really, PC1 is not able to access PC2. For that, here I have PC1. First of all, let me check the IP configuration. So IP address is, you can see, correct 10.1, and gateway IP address is also, you can see, correct 192.168.10.254. First of all, I am going to ping the gateway IP address, that is 192.168.10.254. And okay, PC1 is able to ping their gateway IP address. We don't have any problem. Okay, now let me ping PC2 from here. PC1 192.168.20.1 is the IP address of PC2, and you can see really PC1 is not able to ping PC2. Let me check the IP configuration of PC2. Maybe this is the first step, first troubleshooting step. You should check IP address on both computer, and you should ping gateway from both PC. If both PCs are able to ping their gateway and still they are not able to ping each other, then only you need to access router. Okay, so let me take you to R2. Sorry, PC2, and here I am going to run command. So IP address is correct 192.168.20.1, and gateway IP address is also correct 192.168.20.254. Let me ping the gateway IP address from here 192.168.20.254, and you can see PC2 is also able to ping their gateway. That means I have problem between router 1 and router 2. Okay, so what I am going to do, first of all, I am going to check the protocol, which protocols we are running on router number 1. Then we will check the protocol neighborship between router 1 and router 2. After that, I will check what problem we have. Okay, let's see what is the problem there. I will definitely check the routing table also of router 1. First of all, I should check routing table. Okay, so on router number 1, first of all, I am going to run command so IP route. So IP route. So you can see in the routing table of router 1, there is one network with symbol D. That means I am running EIGRP protocol. Okay, and AD value also you can see here is 90. 192.168.20.0/24 network is there. Okay, router 1 have this network 192.168.20.0/24. So I think I don't have any problem on router number 1, because router 1 have this network 192.168. Means if PC1 will ping 192.168.20.1, which is the IP address of PC2. Let's say, let me make you understand like this. If PC1 is pinging to 192.168.20.1, means PC2 source IP will be 192.168.10.1, and destination IP will be 192.168.20.1. Right, source MAC will be the MAC address of PC1, and destination MAC will be the MAC address of gateway. PC1 will forward this to switch will forward it to router. When router will receive it, router is going to check their routing table directly. Actually, it will check SAP table. So IP SAP table, and in SAP table also you can see there is one entry for 192.168.20.0 network. Okay, exit interface is fast ethernet 0/0, and next hop IP address is 12.1.1.2. okay, because this network is available in routing table. Okay, so through routing table, when I am checking routing table, then I am also getting router 1 is learning this network through which routing protocol. So it is learning through EIGRP protocol. Okay, so router 1 will forward traffic towards 12.1.1.2 to router number 2. Now router 2 will forward this traffic to router number 2 switch, and switch will forward to PC. When PC will generate reply, because when PC will generate reply, then source will become what, 20.1, and destination will become what, 10.1. Destination will become 10.1. It will forward to switch, switch will forward to router 2, and router 2 should have one route in their routing table for 192.168.10.0 network. So let me check routing table. So IP route. Oh, routing, inside the routing table of router 2, I am not able to see 192.168.10.0 network. Okay, that means router 1 have learned this network LAN 2, but router 2 have not learned the network of LAN 1. Okay, so I need to troubleshoot it why router 2 have not installed this prefix in their routing table. And guys, the first thing which is coming in my mind is, maybe on router number 2, we have filtered the prefix. We have filtered 192.168.10.0 network, because if R1 is getting the prefix, this prefix LAN 2 prefix, that means there is neighborship. We don't have any problem with EIGRP neighborship on router number 1. You can see, so IP EIGRP neighbor. So 12.1.1.2 is the neighbor, don't have any problem. Q count is 0, sequence number is 5. If Q count is 0, that means we don't have any problem with EIGRP. On router number 2, if router 2 is not receiving 192.168.10.0 network, so maybe engineer or someone have configured the filtering. So let me check the filtering. First of all, first thing which is coming in my mind is, maybe on router number 2 there is one filtering. So let me check. So IP protocol, through so IP protocol I can check, is there any filtering in EIGRP. So you can see here guys, outgoing update filter list for all interfaces not set, and incoming update filter list for all interfaces not set. That means filtering is not there, right? Filtering is not there. Because of filtering, router is no this is not true, that because of filtering router 2 is not receiving this prefix. Then what can be the problem? Problem can be anything. So IP EIGRP neighbor. Okay, so here also Q count is 0, neighbor is 12.1.1.1. Everything is fine. Let me check the topology table, because if there is no filtering, then you will check topology table, that is router have this prefix in their topology table or not. Okay, like on router number 1, if you will check topology table, definitely 100% inside the topology table this prefix will be there, 192.168.20.0, because this network is in routing table. So IP EIGRP topology, in topology table you can see this network is also there and this network is also there. Definitely this network will be there. Okay, on router number 2 I am going to check topology table. So IP EIGRP topology. So inside the topology table, inside the topology table we are able to see this prefix 192.168.10.0/24, 0 successor. For this network, 0 successor, and this network is reachable via 12.1.1.1. Let me do one thing. If this network is in topology table but not in routing table, then I am going to open this prefix in detail. So IP EIGRP topology, after that 192.168.10.0/24. If you will open this prefix in detail, you can see the delay. Delay is in picosecond. We are running, I think, EIGRP named mode. So IP protocol, we are running EIGRP ES number 100, and so IP protocol summary EIGRP. Through this command also you can check. And so IP EIGRP topology. Inside the topology table we are able to see this is EIGRP CCNA. Okay, named mode EIGRP is running between router 1 and router 2. Name is CCNA. In the topology table a prefix is there, but in routing table prefix is not there. Then I am going to check this prefix in detail here. So IP EIGRP topology and 192.168.10.0/24. Okay, so FD is what? This is the FD value. Okay, so router 2 have calculate FD value also, and this is internal route. Fine, we don't have any problem. Hop count is okay, 1. MTU is this one. Reload, reliability, everything is there. And originator router ID is 192.168.10.254, means router 1. Okay, here I am not able to see any problem, right? In topology table everything is fine. Then why router 2 is not receiving it in their routing table? Now the second thing which is coming in my mind is, if a prefix is inside the routing table but topology table but not in the routing table, and we are running EIGRP named mode. So guys, as you know, EIGRP named mode calculate 64 bits metric. This is 64 bits metric, but router can install 32 bits metric in their routing table only. Router can install only 32 bits in their routing table. So we have one concept, that is rep scale. Through rep scale it will divide the metric. So let me check what is the value of rep scale. If here engineer by mistaken engineer have configured rep scale 1, or anyone have configured rep scale 1, then definitely it will not install this prefix in their routing table from the topology table. So that can be this can be the one possibility, that why prefix is not in the routing table but prefix is in topology table. So for that I am going to check show IP protocol. I'm going to run show IP protocol command, and exactly here you can see metric rep scale value is 1. So this is problem here, because if rep scale value is 1, then EIGRP will divide metric by 1 and then it will install in routing table. But if metric is more than 32 bits, then it cannot install in routing table. Or what you can do, you can check all commands that engineer have run in EIGRP mode. So run section EIGRP. So here also we can say network, okay, this one is fine, this one is fine. Here see metric rep scale 1. This is the reason. This is the reason why router 2 is not installing this prefix 192.168.10.0 prefix in their routing table. So metric, in case of EIGRP named mode, metric scale should not be 1. Otherwise it will not install any prefixes who will have metric of more than 32 bits. By default rep scale value is 128, so I am going to set rep scale value 128 on router number 2. Okay, so let me go to router EIGRP, name was CCI, and you already know how to verify the name. Okay, name CCI, after that address family IPv4, and autonomous system number is 100. We have checked it, autonomous system number was 100. So IP protocol, here you can see. So I am going to say autonomous system number 100, and here you will run command metric rep scale, and I am going to set again 128, that is by default. Okay, and now I am going to check so IP route EIGRP. In the routing table still router have not installed the prefix. Okay, so now what is problem? So IP EIGRP topology, inside the topology table prefix is there, but still it is not receiving in routing table. This time metric is this one, and I have configured rep scale 128. So what problem can be, here, if router is not installing this prefix in their routing table, that means maybe after dividing this metric with value 128, it is not getting the metric of 32 bits or less than 32 bits. That can be the possibility also. So because of that also the router will not install the prefix in their routing table. So IP route EIGRP, through EIGRP it have not learned any prefixes. So I am going to set, let's say rep value, I am going to set rep value 255. I can set rep value up to 255. So let me set up to 255 here, to check that router is installing it in their routing table or not. If still it will not install in the routing table, then I am going to check the bandwidth or delay of these interfaces. because fast here between router 1 and router 2 I am using fast Ethernet link, and my LAN users are also connected through fast Ethernet link. So router should receive the prefixes, it should install it in the routing table. Okay, so first let me set rep scale value 255, and after that if it will not install in the routing table, then I will check the running configuration of all interface. So go to router EIGRP, CCIE, and address family IPv4, and autonomous system number is 100, and say metric rep scale 255. First of all let me verify so IP protocol that rep scale value is changed or not. So now you can see rep scale value is 255, and on router number 2 I am going to check routing table. So IP route EIGRP. So still it is not receiving the prefixes. Okay, still it is not receiving. So IP EIGRP topology, inside the topology table prefix is there, but you can see metric is very large. Metric is very large, that is not possible on fast Ethernet link. Okay, so I am going to check bandwidth and delay of all receiving interface. Okay, so let me do one thing. On router number 2 I can tell to router 2 one more thing, that use any other k values, not k1 or k2, k3 for the metric calculation, then also it will install the in the routing table. But that is not the correct way, but let me show you guys. Through that also you can achieve your task. You can install the prefixes in the routing table. Router EIGRP CCIE address family IPv4 autonomous system is 100, and here I am going to say, first of all I am going to remove rep scale value metric rep scale. Let me set default value, that is 128. Okay, the default is the best value. After that here I am going to say metric weight, and metric weight, this bits will be always 0. After that k1 I am going to say don't use k1 value, and I am going to say use k2 value, and I am going to use k2 means 1, and I am going to say no, don't use k3 value also, don't use k4 value also, don't use k5 value also, and don't use k6 value also. So I have tell to router 1 only use k2 value. Okay, so never shift will goes down on k values will mismatch, neighborship of EIGRP will goes down. I have copied this command and I am going to run the same command on router number 2 so that neighborship can come up. Router, first of all here I have to verify the name of EIGRP process. So do so IP EIGRP topology. Okay, name is here also CCIE. So router EIGRP CCIE, and autonomous system number do so IP protocol. Autonomous system number is also 100. So let me say address family IPv4 autonomous system number 100, and metric weight. I am going to copy the command from this router. Okay, sorry. Okay, let me set manually. Metric weight 0 0, k2 value yes 1, and don't use k3, don't use k4, don't use k5, and don't use k6. Now just wait, guys. I will remove this command, by the way. Just I am checking do so IP route EIGRP. Now you can see this router have installed this prefix in their routing table, and now PC1 can ping to PC2 as well. From PC1 I am going to ping again 192.168.20.1, and see this time I think ping should work. You can see ping is working, but I am not going to change the metric value. So first of all let me run no command on both router. Here also I am going to say no to this, and I will do same thing on router number 1 also. I'm going to remove this command. This is R2. Let me do same thing on R1 also. Say no. Again EIGRP neighborship will come up. Just wait for some time, and again now you can see routing table. Do so IP.EIGRP. It is not receiving the prefixes. Now see, by default delay on fast Ethernet link is 100. So this is the receiving interface for this network. Whenever it will receive this network 192.168.10.0/24 10.0/24, this interface is also receiving interface, and this interface is also receiving interface. So I am going to check bandwidth and delay on both interface. Okay, so bandwidth should be 100 Mbps and delay should be 100. Okay, on both link. Fine guys, getting my point what I am saying? The see, router 2 is not receiving prefixes 192 prefix in their routing table, but prefix is there in the topology table. Do so IP EIGRP topology, because the metric is very high for a particular prefix. So I am going to check delay and bandwidth of receiving interface. Okay, so first of all let me check the show run interface f0/0. Here if you will change the bandwidth or delay, I can see the command, but I am not able to see any command here. That means you have not set delay, or engineer anyone have not changed the delay value. Or I can run command show interface f0/0, and then I can say interface, sorry, include bandwidth. So you can see bandwidth is 100 Mbps, that is default bandwidth, and delay is 100. Okay, that is also default on fast Ethernet link. So fast Ethernet 0/0 of router 2 is like default configuration. Now let me take you to R1. On R1 I am going to check the configuration of, first of all I am going to check delay. So interface f1/0, delay and bandwidth of f1/0, because this interface is receiving interface, right, for 192.168.10.0 network. So say bandwidth here. Okay, here you can see bandwidth is fine, but delay, you can see delay is very high of fast Ethernet 1/0. Okay, so run interface f1/0. You can see in this particular interface we have set this value as delay value. So first of all let me remove the command interface f1/0 and say no to this, no to this. Okay, and now on router number 2 I am going to check, because see router 2 have still repay skill value is default, not 1. So IP protocol repay scale value is default, that is 128, and if I will configure repay scale value 1, then also it will work, I think. So IP route EIGRP, and now you can see it is receiving this network. Okay, and so IP EIGRP topology. In the topology table you can see this is the metric value, and in the routing table you can see this is the metric value. So both metric value is different. So as I told you that in EIGRP named mode, router will divide metric of topology table with repay scale value, and then whatever value it will get, that will become metric for routing table. Okay, and if I will set repay scale value 1 over here, because earlier repay scale value was 1 here. Okay, then also maybe it will work or it will not work. So router EIGRP ES number, sorry, CCI and IPv4, sorry, address family IPv4, address family IPv4, unicast, and autonomous system number is 100, and metric repay scale 1, and do so IP route EIGRP. Still it is receiving in the routing table. So we don't have, we maybe repay scale is configured on router number 2 for different purpose. So that's why I have set repay scale value again 1 on router number 2. Okay, now I am going to save the configuration I will save the configuration of router 1 also, and you can see now LAN user are able to communicate. That means I have troubleshoot the network, guys. I have verify the problem, then I have troubleshoot the problem. Okay, and you can see now LAN user are able to communicate with each other. There is no any problem now. Fine. So just this was a small troubleshooting. If you have learned something from this video, please hit on like button, and we are going to meet in next video. Till then, stay safe. Bye bye.